So in this video we're gonna discuss about the complex salts. So molecular addition compound in which individual component loses their identity and its aqueous solution doesn't give positive test of all constituent ion is called the complex salt. So in which all the constituent ion doesn't give their test, means not every ion give their test. That's why it is known as complex salt. And we have seen previously in double salt, each and every compound after dissolving in water give its own test, but it is not in case of complex salt. It is not mandatory that each and every compound will give their test. So let's take an example of FeCN2 plus 4KCN. If we form this complex which is known as potassium ferrocyanide, this is a complex ion. So in this complex ion, it will not give the test of iron, it will not give the test of cyanide, but it will give the test of potassium, and it will give the test of this complex salt. Means Fe we will not be able to detect after forming this complex, and cyanide we will also not be able to detect. So let's see, if we have this K for FeCN6, it will 4K plus in aqueous form and FeCN6 minus 4, which is known as ferrocyanide complex anion. Now when it will dissolve in water, it will give iron and 6 cyanide, but it is very low concentration, so it is not sufficient for positive test. So it is very low ion concentration. Let's say if FeCN6 dissolve in water, it is very low concentration. Why it is very low concentration? Because FeCN6 exists like this, when iron is a Lewis acid and these are Lewis ligand base. Okay, so iron is getting electron from these also. It is a complex compound, so cyanide is already occupied over here, so it is not free in water. When it is free, it is very low concentration. It's that low concentration that it will not be able to detectable in the compound. So now let's see if we take another example, FeCN3 plus 3KCN, it will form K3 FeCN6. When we dissolve into water, it will give 3K plus and FeCN6 minus 3. Again, it will form a very low concentration that it is not sufficient for positive test. So types of complex salt. So on the basis of the degree of ionization of complex ion, complex salts are further divided to two parts. One is perfect complex salt and then one is imperfect complex salt. So let's see what are the perfect complex salts. So these complexes are stable enough when their aqueous solution does not give positive test of all the constituent ion due to negligible degree of ionization of complex ion. Again, we call the perfect complex salt or the salt or the complex salt which do not complex ion which do not give their test, which are very negligible degree of ionization. So let's see an example, like if we have CuCN copper cyanide. So copper cyanide itself is a white PPT. It is a simple salt. It will mix with again simple salt. It will form K3CuCN for a complex. When we dissolve that complex into water, it will form 3K plus and CuCN4 minus 3, which is known as cyanocomplex anion. And it is perfect complex with respect to H2S. It is perfect complex with respect to H2S. What does it mean? Well, let's see. First of all, when this complex is formed, it will be forming 3K plus CuCN4 minus, which is a cyanocomplex anion. And further, cyanocomplex anion is dissolving like this, which is a low concentration, so it will not give the positive test. So as we know, let's see why we call it as a perfect complex with respect to salt H2S. As we have seen that copper, when it is in +4 +1, it goes disproportionation. Disproportionation means one mole of the compound will reduce, 1 mole of copper plus will reduce, and 1 mole of copper plus will oxidize to Cu plus 2. So whenever we pass the H2S gas from this copper, so copper actually exists in Cu plus 2 and Cu. So Cu plus 2 will forming a complex of CuS, and it will be having Ks. The value is less than, the concentration is less than Ksp due to very negligible concentration of Cu plus 2. It is a very negligible concentration, that's why it is less than the value of Ksp. Their solubility product is less than is less. Okay, Q is less than Ksp, that's why we will not be able to detect the copper ion. So that is with respect to H2S. Okay, so it is perfect complex with respect to salt, with respect to H2S. Let's talk about the imperfect complex salt. So these complex are relatively less stable and their aqueous solution give positive test of all constituents ion due to appreciable degree of ionization of complex ion. So that's the difference between the perfect complex salt and imperfect complex salt. It gives the test of the individual, it gives the test of all constituent ion due to appreciable degree of ionization. So it has appreciable degree of ionization. Let's see an example, like we have CdCN2 cadmium cyanide, which is a simple salt, and with 2 KCN it forms K2CdCN4, which is a imperfect complex salt with respect to H2S, but it is perfect complex salt with respect to HCl. So it is not mandatory when it is imperfect. So it is imperfect to respect to every gas or every detectable gas we use, which is help to detect the ion. So let's say if it is imperfect, it is imperfect complex salt with respect to HCl, but not imperfect complex salt with respect to HCl. So according to H2S, it is a perfect complex salt, or it is a perfect complex salt with HCl. Imperfect complex salt with respect to H2S, but perfect complex salt with respect to HCl. So let's see, it will form 2K plus and CdCN4 minus 2. Again, CdCN4 minus 2 will having a very Cd plus 2 and 4Cn minus. The K value might be a little bit more. So when HCl gas is passed, it will be having no PPT, so it is perfect complex with respect to HCl. But when we pass the H2S, it will. So let's see, when CdCN2, when HCl gas is passed, it is a perfect, no PPT we will be having, so it is a perfect with respect to HCl. But when we pass the H2S gas, we will be having the yellow PPT of CDS. So when we will be having yellow PPT of CDS, means we have detected the cadmium is there. So that's how we call it as a imperfect with respect to H2S. So we have seen previously, it is imperfect complex salt with respect to HCl, and it is perfect complex salt with respect to HCl. So from above discussion, it is clear that perfect and imperfect nature of complex salt does not only depend upon degree of ionization of complex ion. However, it is also depends upon the nature of reagent used for precipitation, like KSP for precipitate salt. So whenever we have given the value of KSP, we can identify whether the salt is perfect or imperfect with respect to that reagent.